Warm greetings and welcome, dear audience. This is Dr. Esther Mala, your firstly and successful global educator, SDG, ESG, STEM and technology enthusiast from Malaysia. Dear respected, precious audience, esteemed academician, and our dedicated project team of Elegant Empire Education welcomes you to another professional masterclass with a new series on research, understanding research. Today is the first lecture. Uh, the topic will be fundamentals of academic research. Yeah. So for this, we have an awesome and brilliant personality, Professor Dr. Rania Lampu here with us. She's not a stranger for all of you. I'm very sure you know her. She's an international speaker, a researcher, an author, and many, many more. Okay, today she'll be starting on the research series with us. Join our exclusive masterclass on STEAM and featuring latest technology and management skills designed for university students, college learners, and working professionals and lecturers. Led by distinguished academicians and industry experts, this program explores cutting edge innovation in management science, technology, engineering, arts, and mathematics. Gain insights into AI, robotics, data science, IoT, and more. While understanding their real world application, this masterclass aims to enhance knowledge, foster innovation, and create awareness of rapidly evolving technological landscape. Stay ahead in your field by equipping yourself with essential skills and future ready expertise. Empower your learning, elevate your career. Welcome. Let's welcome our honorable and beautiful masterclass trainer for today, Ambassador Professor Dr. Rania Lampu. The stage is yours. Welcome. You're muted.
Yes, thank you so much, Dr. Estera. Good evening, good afternoon from Greece, from Athens. Happy National Labour Day. But we are working all the time. We never stop.
Yeah, we are working all the time. Yes. For us,
Even
holiday
today.
and workday, weekends are all same.
Exactly.
Yeah, but we have liberty to choose our rest. That's the wonderful thing.
It is with great pleasure that I welcome you all, me too, to the launching of our brand new series of research sessions. And these series are precious, are valuable. Why? Because we want to explore research topics from beginner to advanced level. So whether you are beginning your academic journey or looking to strengthen your understanding of the research process, you are in exactly the right place. Academic research is more than just gathering information. It is the cornerstone of progress, innovation, and critical thinking in every field of study. Today, we will explore what research truly means, why it matters, and how to approach it with clarity, curiosity, and purpose. So, these sessions are designed to demystify the research process and provide you with essential tools and insights to build a strong foundation. From understanding the role of a research question to exploring reliable sources and ethical guidelines, we aim to make research accessible and engaging to all. Of course, throughout the sessions, we encourage you to ask questions. You can write on the chat box. We can participate actively. You can think critically. So once again, welcome. So let's embark now on this exciting journey to the world of academic research together. I would like to thank Elegant Empire Education for this wonderful opportunity, and especially you, Dr. Estera, for your suggestion and your invitation. So now I will start sharing my presentation. Dr. Estera, is it visible?
It's not that yet because you have to upload. You have to upload your file, your PPT file. You have to
No,
go to
every
present.
time.
Oh no, here I don't see your file here. That
Yes.
Zoom is different. Yeah, Just go to
No,
present.
because
Just go to present, slides
wait,
and
wait,
PDF.
wait, 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 wait. I got it. I got it.
Yeah, it's coming up. Yes.
Now,
And
now at least.
yeah, yeah.
Okay,
How
can
did
you
you upload this? There's two. Is that you're having
full
two
screen?
computers? Oh,
Full
two
screen.
screen. Okay, fine, fine,
Yeah. Hi.
fine.
Can you see also the change of slides?
Yeah, yeah. I can see the
Okay.
slides.
Okay. Okay.
Yes.
So, when we talk about understanding research, academic research is a systematic and methodological investigation which is carried out in order to discover, to interpret, or revise facts, theories, application, or laws within a scholarly discipline. So it's always driven by a desire to advance knowledge, to solve specific problems, or contribute to academic discussions following recognized standards of rigor, objectivity, and critical analysis. So, key characteristics. What are the key characteristics of academic research? It follows always a clear methodology, including planning, data collection, see, data analysis, interpretation, all the stages where we have a time to explore it in details throughout this series of sessions. So don't worry about this, everything will be clear. So we talk about how the first characteristic is a systematic part and structure aspect. Conclusions are drawn based on empirical data, logical reasoning, or established theories, not personal opinions, so objective and evidence-based. It's also research is focused on question and hypothesis. Academic research usually seeks to answer a specific research question or test a hypothesis. It contributes to knowledge because it aims to fill gaps in existing literature, propose new ideas, refine theories, or apply knowledge in new ways. And also, it's peer-reviewed and transparent because academic research is typically shared through publications that undergo peer review, ensuring quality, validity, and reproducibility. What about ethics? Ethics, I think, is the most important part now, since we're living in an era of AI and ChatGPT. So research must follow specific ethical guidelines, ensuring integrity in order to maintain our ethical and academic integrity, respect for subject, and honesty in reporting results. So first, we'll talk about types of inquiry. It's about first troubleshooting. Diagnosing why a machine isn't working by trying different fixes. It's about exploration, browsing articles out of curiosity without a specific goal. Brainstorming, you all know about this, how we generate ideas without testing them yet. And fact-finding, looking up existing information without generating new insights. Here, you need to know, to understand how research is different from other forms of inquiry or investigation. Research, I mentioned before, it is systematic, methodological, methodical, and purpose-driven process aimed at creating new knowledge or confirming or finding existing knowledge. So this is what research, what we call research. In contrast, other forms of inquiry or investigation are usually less structured, less rigorous, and may not aim to generate broadly applicable knowledge. So here you can see some difference in terms of purpose. The research aims to discover knowledge, test hypotheses, other inquiries to solve an immediate problem, probably or to satisfy curiosity. Research is highly organized. Inquiries are often informal. Research requires critical evaluation, reproducibility, evidence-based conclusions, peer validation. On the other hand, inquiry may rely on intuition, trial and error. Research aims for results that are generalizable or contribute to a broader body of knowledge. On the other hand, inquiry typically is context-specific. So this means that the results may apply only to the immediate case. In terms of documentation, research includes a detailed recording of procedures or process. On the other hand, inquiry, then documentation may be minimal. And of course, research should adhere to strict ethical guidelines. So ethical guidelines may not be formally considered. On the other hand, if we talk about investigation. So what are the main purposes of academic research? The primary goal is to contribute new information, new theories, new concepts, or insights to a particular field. Example, a study on renewable energy technologies that proposes a more efficient solar panel design advances engineering knowledge. And why matters that because fields like medicine, engineering, or social sciences and the humanities grow through continual addition and refinement of knowledge. Secondly, problem solving, because in order to find solutions to specific practical theoretical problems, research is very important here. For example, research into better water filtration, better filtration systems to solve clean drinking water shortages. Why this is important? Because academic research often seeks to address real-world challenges and improve quality of life technologies or policies. Academic research entails always critical analysis evaluation because it means that the primary goal here is to question, to test, evaluate existing knowledge, theories, and practices. Example, a thesis that challenges existing psychological models of learning and proposes alternatives. And why it is important? Because progress depends not just on adding new ideas, but also on refining, improving, or discarding outdated models. Exploration curiosity. To satisfy intellectual curiosity and explore unknown areas without necessarily seeking immediate practical applications. For example, research into the behavior of particles at the quantum level. Why it is important? Because much of today's technology, like the internet or MRI machines, stems from basic research that wasn't initially conducted with practical outcomes in mind. Education skill development in order to train students and researchers to critical thinking, to problem solving, to methodological skills and communication. Research is crucial. For example, a master thesis project teaches students how to design experiments, how to analyze data, how to interpret skills. And why it matters? Because engaging in research develops essential skills that are useful both inside and outside academia, such as analytical thinking, data management, and effective writing. Informing policy and practice. You know that the research has been can be very enriched through policies and practices in order to provide evidence-based recommendations that inform public policy, business practices, professional standards. Research is there, and from one point, research can be enriched by policies, and policies can be enriched by evidence-based strategies. So we can say that it's a two-way situation. And why it matters? Because policymakers, industries, and organizations rely on rigorous academic research to make informed decisions that affect the communities and the economies. Innovation, technological development. We drive innovation by providing the foundation for new technologies, products, and systems. This is the goal here. Economic growth and social progress are closely tied to innovations that often stem from academic research. Of course, it's about preservation, interpretation of culture, theoretical development, how to foster collaboration, especially nowadays. Collaboration among researchers is very easy, thanks to all these virtual online platforms. And now, we are at the heart now of the research process and design. What are the main steps involved in the academic research process? The first thing we need to do is to define the research problem. The academic research process is always a structured method for investigating questions, for solving problems, or contributing new knowledge to a field. And it usually follows these main steps. You choose a topic. Select a subject that interests you and is relevant to your field. Then you need to narrow the topic, the focus. Refine broad topics into a specific research question or hypothesis. This is the second step. Define objectives. This means clearly articulate what you aim to discover, prove, or understand. Then review existing literature. Conduct a literature review. We'll have a whole session about this. But today we can say that this means search for existing research, theory, models, and data related to your topic. identify gaps, so find where existing studies are lacking or what questions remain unanswered, and refine your research question based on what you find. You need to adjust the question to be original and meaningful. Formulate a hypothesis research question. What is hypothesis? If we talk about quantitative research, for example, it is a predictive statement that can be tested. For example, you say increased study improves, increased study time improves exam scores. This is a hypothesis that can be measured. On the other hand, for research question, which has to do with qualitative research, here we have an open-ended question exploring a phenomenon. For example, how do students experience online learning? This is an open-ended question related with qualitative research. Then we select the research method. So we choose between qualitative or mixed methods. Mixed methods usually are the best because they include both. And we define data collection techniques after. Options include surveys, experiments, case studies, interviews, or archival research. Then we have the plan for data analysis. We decide on statistical methods, on coding techniques, or thematic analysis depending on our data type. And ethical considerations, of course, we need to ensure that our research respects privacy, informed consent. We want to explain what is informed consent, and ethical standards, which often requires institutional approval. Then we collect the data. We execute the research plan. We gather data using the methods that we have chosen, and we always try to maintain accuracy and integrity, so we keep detailed records and follow protocols exactly to ensure reliable and valid results. Then we analyze data, we process the data, we organize, clean, and prepare data for analysis. Then we perform analysis. If it is quantitative data, then we use statistical methods. That could be tests, regressions, etc. If it's about quantitative research, then code transcripts or notes to identify patterns and themes. And then we interpret the results. We need to understand what the data say about our original research question. So collection of data, analysis of data, and to draw conclusions, compare findings to hypotheses. This means we can formulate questions like, do the results support or contradict our initial expectations? Then we relate findings to literature, discuss how your results fit within the broader academic context. Then we discuss implications. What do your findings mean for theory, for practice, or future research? Then we report and communicate the results through a research paper, through proper citations, or through publications, etc. We reflect, evaluate, finally, through assessment of our process, of our results, we think about what worked well, what could be improved, identify limitations, we acknowledge our weaknesses or constraints in our study, and always suggest future research, propose how others might build on your work. So each step, of course, it's interconnected. And often researchers look back to earlier stages as they refine and they adjust the project based on what they discover. So how do you formulate a good research question? Formulating a good research question is one of the most critical steps in any research project, especially in technical fields like mechanical engineering. A strong research question guides the study, focuses your efforts, and defines success. So first you need to identify a broad topic of interest. You start with a general idea you're passionate about or whether there is a real world problem. Examples in mechanical engineer, heat transfer or robotics or fluid dynamics or energy efficiency or manufacturing processes, etc. Then you narrow the topic based on gaps or problems. Narrow the topic and review existing literature mentioned before, find what has been studied, where gaps remain. You identify practical problems, real-world needs, That could be, for example, we need lighter aerospace materials or better cooling systems. Real-world needs often point towards good research questions. And you look for contradictions. If different studies show different results, there is room for further research. Then you apply the final criteria. A good research question should be feasible. Can you realistically study within time, resources, skill limits? It should be interesting. Does the question intrigue you and the broad research community? It should be novel, original. Does it add new knowledge, methods, or applications? It should be ethical. Can the research be conducted ethically and relevant? Does it address a meaningful issue? And of course, we define the type of research we want to. Is it descriptive? How does X material behave under extreme cold? Is it comparative? How does A compare to B? Causal, what are causes and effect? Exploratory, what's out there? What are the potential applications of AI in adaptive manufacturing, etc.? And then we structure the research question properly. Good research questions are often clear, specific, and focused. So here a few formats to use. For example, we talk about mechanical engineering type questions. For one example, type of question is what is the effect of nanocoating thickness? This is independent variable on the thermal conductivity of copper heat exchangers. This is dependent variable in this system. Or how does regenerative braking, which is here is a process system, improve energy efficiencies? This is performance efficiency under conditions in electric vehicles at different speeds. So this is a condition. Or how can a new method of material, for example, can additive manufacturing techniques, this is new method of material, outperform the current standard? For example, can additive manufacturing techniques produce turbine blades that outperform traditionally forged blades in thermal resistance? Thermal resistance here specific application. So can new materials outperform current study in specific application? See, these things you need to check when you formulate a good research question. You refine through iteration, so you test your draft question. Is it specific enough? It can be measured or analyzed. Is it too broad or too narrow? And get feedback. Ask advisors, mentors, or colleagues for input. A fresh perspective often helps sharpen the question. The common mistakes to avoid when we formulate a too broad question. For example, you say, how can we improve all transportation systems? This is too broad. This is not a good research question. Or when it's too narrow. Or when it is too vague. When you say, for example, is the 3D printing good? This is not a research question. Is it 3D printing good in general? This is very vague. Or unanswerable. Or philosophical question. What is the ultimate future of mechanics? This is not a research question. So, example. The evolution with a research question. Let's see, the first step here, the broad topic, heat dissipation electronics. What we need to do is to narrow down our topic, as I mentioned before. We narrow our focus. So using phase change materials for cooling laptops. The third step, we draft a question. How effective are phase change materials in cooling laptops, laptop CPUs? And the fourth step, we define for specificity and feasibility. So what is the effect of phase change material thermal conductivity on the peak CPU temperature of laptops under heavy load? So we start from the first step and we try to evolve our research question in order to arrive to the fourth step where we finally refine a question to be more specific and feasible, define the criteria that I mentioned before. Now, this is our first initiation with qualitative quantitative mixed method research. I think during our sessions we will go to discuss all the time about these things. So very briefly today, just initiation. Qualitative research always focus on complex phenomena, the experiences, or concepts in depth. We talk about non-numerical data here. That would be words, images, observations. That would be interviews, focus groups, open-ended surveys. The goal is to understand meanings, interpretations, and patterns from participants' perspectives. The example study how cancer patients emotionally cope with treatment through interviews. Quantitative research, always what is the focus? Test the hypothesis or measures variables numerically. The numerical statistics, measurements, closed-ended survey responses. So what is the goal? Is to identify patterns, predict outcomes, or establish cause and effect relationships. For example, we measure how a new drug affects blood pressure compared to a placebo in a clinical trial. And mixed method research, I say that is always the best. It combines both qualitative and quantitative approaches in one study. What is the data type here is both numerical and non-numerical. And the goal is to gain a fuller, more comprehensive understanding by integrating numeric trends with detailed personal insights. So, for example, surveying students about test anxiety, which is quantitative, and then conducting interviews to explore their experiences in depth. This is qualitative. At the same time, so we could say that qualitative is a deep understanding of how and why. Qualitative is measurable evidence of how much and how often, and mixed methods. It contains both, because we need here a holistic picture. So what is a research hypothesis? Mentioned before, how we can formulate a good research question. So now, what is research hypothesis? How it is different from research question? A research question I mentioned before, it is a broad inquiry that the research seeks to answer. It identifies the main focus of the study without predicting an outcome. So research questions guide the study's direction and frame the hypothesis. For example, does the amount of sleep before an exam affect student performance? This is a research question. What is the difference between the research hypothesis? A research hypothesis is a specific, testable statement that predicts the expected outcome or relationship between variables in a study. So it's a formal guess based on existing knowledge, on theory, or a theory that the researcher then tests with data. For example, students who sleep at least 8 hours before an exam will score higher than those who sleep less. The key difference is that research question asks what you want to find out. A research hypothesis states what you expect to find based on theory or prior research. And the research question comes first. The hypothesis is developed from it. I hope it is clear. Now, literature review. Literature review, I mentioned before that it systematically examines, discusses, and synthesizes the existing research work, which is related to a particular research question or area of inquiry. And it always presents what is already known, what gaps exist, how theories and methods have evolved, and where your research fits into the bigger picture. Here you can see what is the purpose. It contextualizes your research. Why it is important? Because it shows where your work fits among existing studies. Identifies gaps, so it reveals unanswered questions or areas needing deeper investigation. It avoids duplication because it ensures that you're not repeating research already done. Builds a theoretical framework. Why? Because here it is important we try to establish new theories and new models and new concepts that we're going to use throughout our thesis. And strengthens research design by reviewing methods used in past studies. We can design stronger experiments or methodologies. It demonstrates expertise. It shows that you understand the field by building on solid foundations, and it justifies your body means by showing a gap or need. You justify why your research is valuable and necessary. So, what are the key components of a good literature review? The summarization, condensing key points from previous studies, the synthesis, connecting ideas and showing how studies relate to each other, analysis, critiquing means challenging methods, findings, and conclusions are not just accepting them. An organization structuring content logically by themes, chronologically, or by methodologies. And gap identification, highlighting missing pieces that your research can address. For example, a mechanical engineer context again. Suppose that you are you are studying energy efficient gearbox designs. In the literature review, you will do what? You will try to summarize key developments in gearbox efficiency, materials used, common design challenges, and previous solutions. You would critically compare findings after, highlight disagreements or limitations in prior work, and then point out that no one has yet studied gearbox designs optimized for a new type of lightweight alloy, which becomes your research niche. So literature review shows that you are standing on the shoulders of others, not reinventing the wheel, of course, but it helps explain why your research needs to exist. So how can a beginner effectively find and select relevant academic sources? You need, as I said before, to clearly define your research question or topic. This means start narrow, avoid vague topics like climate change, and define something specific, like impact of climate change on coastal agriculture in Southeastern Asia, for example. So why? Because a well-defined question helps you find more targeted and relevant sources instead of getting lost in a sea of unrelated articles. After, you need to use academic databases, not just Google. This means that you need to explore all these recommended databases, the Google Scholar, PubMed. For engineering, there are many also amazing platforms that you can explore. This store Science Direct Scopus, Scopus of Web of Science for broader scientific research. We can speak a lot about Scopus and about academic publishing, what we can do there. Academic databases give you access to peer-reviewed, credible, and citable sources. Regular Google searches often return blogs and new articles on academic websites. So this is why recommended databases are important. And use strategic search techniques. What is the keywords here is to identify 3 to 5 main keywords from the research question. Use operators like what we call Boolean operators like enter to combine climate change, for example, in your search, and coastal agriculture, or for alternatives, global warming or climate change. Not to exclude climate change, not politics. So these are what we call Boolean operators. Quotation marks use codes for exact phrases, renewable energy adoption. Filters use filters like date range or subject area or document type to narrow down search results. And why? Because this prevents you from getting overwhelmed with irrelevant sources and focus your research. You start with review articles and meta-analysis. Review articles summarize lots of research on a topic. Meta-analysis statistically combine results from multiple studies. And why it is important? Because they give you a broad overview. It can help you quickly understand the main debates, trends, and gaps in the field. You evaluate sources critically. When you find a source, you need to assess it, evaluate it based on authorship. Is the author an expert in the field? So check the credentials. Publication, is it published in a reputable peer-reviewed journal? The date, is recent enough to be relevant? The relevance, does it directly address your research question? Citation, is it frequently cited by others? Highly cited papers are often influential. And use reference mining, what we call backward searching. Look at the bibliography of good papers you find earlier sources that the paper cites, and why it is important because authors usually cite the key foundational studies in their field, helping you find more important sources efficiently. You track them and organize sources early. You use reference managers like Zotero, Mendeley, and Node. You try to organize sources by topic or argument using folders, notes, or tags. And why it's important? Because this keeps your research organized. Keeping your research organized saves a huge amount of time later when writing your literature review or bibliography. And we ask for help when it's needed. University librarians are experts in helping you find reliable sources. You ask for recommended reading lists or advice on key journals in your field. That could be, for example, many universities offer online how-to guides for searching academic databases, so research guides are also useful. And of course, you need to stay skeptical and disciplined. This means avoid using the sources just because they're easy to find, or stay focused on quality over quantity. Always cross-check information if a claim seems surprising, controversial. Practice, practice, practice. I would say the more you practice searching and selecting academic sources, the faster and sharper you will become. You will gradually learn which journals are respected, which keywords yield the best results, and how to spot quality at a glance. So, in short, we could say we define a clear topic, we search smartly, we evaluate critically, and we organize carefully. This is the beginner's roadmap to becoming efficient at finding academic sources. Now, what strategies can be used to organize and synthesize information from multiple sources? This is a crucial skill. A crucial skill in academic research, writing, or problem solving. The goal here is to bring together different pieces of information, identify connections, and create a cohesive understanding of the topic. So first, create an annotated bibliography. So summarize and analyze. For each source, write a brief summary of the main points of findings and analyze its relevance to your research. Identify common themes, completing viewpoints or gaps in the research. This helps to organize the information and build a foundation for synthesis. Then use concept maps or mind maps. So visualize relationships. Use diagrams to link ideas and concepts. Place the central theme or research question in the center and branch out with related ideas, theories, or findings. And identify patterns because mind maps can help reveal connections between disparate pieces of information, showing how sources contribute to different aspects of the topic. Then you create an organized database or spreadsheet. This means here we track key information. Use a spreadsheet to keep track of authors, titles, of key arguments, methodologies, and findings of the sources. We categorize them by themes, so we organize the sources by categories, such as methodology, theoretical approach, or subject matter, and this helps with quick retrieval and comparison. And finally, we tag and filter, use keywords or tags to help you group sources by relevant themes or questions for easier analysis. Then we develop a literature matrix. What is this? The table format. We create a matrix with rows representing each source and columns representing key themes or concepts. And why? Because this actually helps you see patterns across multiple studies, such as the key findings, methodology use, theoretical perspectives, capture all contradictions. Then we compare findings. A matrix provides a quick way to compare how different sources address the same issues, and it can highlight inconsistencies or gaps in research. We use the synthesis matrix technique. So we group sources by theme. We try to organize the sources by common themes, debates, or research questions. For each theme, we summarize the contribution of each source. We identify agreements or disagreements. So look for areas where sources agree, conflict, or offer different perspectives. We try to synthesize the information into a broader understanding of the topic. And then we summarize the main idea and create an outline. So after reviewing each source, what you're doing, you extract the most important points or findings and summarize them in your own words. So create an outline, organize these main points into an outline based on the structure of your paper. This helps to maintain focus and ensures that all relevant information is covered. Use synthesis techniques. Compare, contrast, integrate. So compare, first look for similarities between the sources. Are there any common themes or shared conclusions? Contrast, identify differences in viewpoints, findings, or methodologies. Where do the sources disagree or offer alternative explanations? integrate, combine ideas from different sources to form a more comprehensive understanding. This could mean merging complementary ideas or proposing insights based on existing data. Then you develop thematic categories. This includes identify recurring themes, group information into broad themes or categories that could be benefits, challenges, implications, to organize by topic or issue. So short information under these themes, which can guide you in writing the sections of your paper or presenting your findings logically, and be flexible. This means as you synthesize, adjust your categories in order to ensure that they adequately capture the range of perspectives and findings. Creative narrative synthesis, tell a story. Rather than just summarizing each source individually, you can integrate your findings into a coherent narrative that ties together the key points. This allows you to highlight trends and developments in the field that emphasize how the body of research has evolved. You can use transition phases, help the reader follow the flow of your synthesis by using transition phases. You can say in contrast, on the other hand, so the transition phrases like this. You can use software tools for organization, reference management tools. So the most popular I mentioned before, Zotero, EndNote, or Mendeley. We're going to see about this. Or note-taking apps, highlight the key arguments or findings. So create a key argument summaries, for example. Develop a conceptual framework theory. So identify the line theories, map out concepts, and synthesize critically, identify gaps or weaknesses, evaluate the quality of sources, and organize a synthesis based on purpose. The ethics in research, what are the main ethical principles that researchers must follow? Of course, honesty and integrity. In any field of research, it is crucial to follow ethical principles to ensure the integrity of the research process and the safety of well-being of all involved. So ethical guidelines are important because they help prevent misconduct and ensure that the research is reliable, valid, and contributes positively to society. So here, you can see what we call honesty integrity. So this includes truthfulness. Researchers must present their findings, data, and interpretations honestly. This includes reporting accurate results, whether they support the hypothesis or not, and acknowledging limitations and uncertainties in their work. Avoiding fabrication and falsification. Researchers should never fabricate data or manipulate research results to fit with the desired outcome. This is important, and also transparent reporting. All methods, processes, and results should be transparently reported so others can verify and replicate findings. Objectivity. Objectivity includes impartiality. Research should be conducted without bias. Researchers must ensure that personal beliefs, interests, or affiliations do not influence the design, the data collection, or interpretation of results. Eliminating conflicts of interest. If a conflict of interest exists, for example, funding from an organization that could benefit from certain outcomes, it must be disclosed in order to ensure that it does not compromise the research process. Unbiased interpretation, data should be interpreted based on evidence and not shaped to fit the preconceived conclusions. Respect for intellectual property, this includes how to acknowledge others' work. So researchers must give always credit to prior work, theories, and findings by properly citing sources and acknowledging the contributions of others. Avoid plagiarism. When we use someone else's ideas or work without proper acknowledgement is unethical and unacceptable. And to talk about patents, patent and copyright compliance, researchers must respect intellectual property laws, including patent rights, copyrights, and trademarks, and obtain the proper permissions when using proprietary data or technologies. Confidentiality, this has to do with data privacy, respect for human-animal subject, how to minimize harm, etc. The accountability and responsibility. Researchers are responsible for the accuracy, for the integrity, for the ethical conduct of the research, and they must ensure that their findings contribute to knowledge in a responsible way. Peer review and feedback, researchers should participate in the peer review process and be open to receiving constructive criticism to improve the quality of their work. Acknowledging, of course, funding sources. If the research is funded by external organizations. Researchers must disclose this information in order to avoid potential biases and conflicts of interest. The social responsibility, how to benefit society. Research should aim to advance knowledge and contribute positively to society. This includes considering the social and environmental impact of the research, particularly in fields like mechanical engineering mentioned before, where innovations may have wide-reaching consequences. For example, new materials or energy technologies or industrial applications. Try to avoid harm. Researchers must ensure that their work does not cause harm to individuals or to animals, communities, the environment. For example, an engineering design should be tested for safety in order to avoid adverse effects on human health and the environment. And research findings should be shared in a way that benefits the public. Open access publication, data sharing, knowledge dissemination help ensure that research contributes to public good. Transparency and openness, what we call reproducibility. Research should be conducted in a way that other researchers can replicate the study. This requires openness about methods, data, and tools used in the research. The data sharing, when it's possible, researchers should share the datasets, models, and methodologies to facilitate transparency and further exploration by others in the field. And of course, disclosing errors or corrections. If errors are discovered in published work, then researchers have an ethical obligation to correct them promptly and transparently. Avoid misuse of research and always search for fairness and equity. Following these ethical principles is essential for maintaining the credibility, ethical, or impact of our work. What is informed consent? You need to know about this. Informed consent in research is the process through which participants are fully informed about the nature of a study and voluntarily agree to participate, understanding the potential risks, benefits, and the rights. So this ensures that participants are making an educated and voluntary decision to engage in research. So what are the key elements here? Information disclosure. Researchers must provide clear, comprehensive details about the study, such as purpose of research, the procedures involved, the potential risks, the duration, participation, how the data will be used and stored. Participants need to understand the information presented. This might include ensuring that they can ask questions and receive answers in a way that they can understand. Or consent must be given freely. We talk about voluntary participation without any manipulation or coercion or undue pressure. Participants should know that they can withdraw from the study at any time without facing negative consequences. Competence, participants must be mentally competent to give informed consent in cases of minors or cases of individuals with diminished capacity. Consent may need to be obtained from a guardian or legal representative. Documentation, typically participants sign a consent form to document that they understand the study and agree to participate. In some cases, verbal consent may be appropriate, especially in certain cultures or under specific conditions, but it must be still must be documented. And why is focus important? Because it protects participant rights and autonomy and ensures that participants are not misled or unaware of the study's nature, and because it helps safeguard researchers from legal issues regarding the treatment of participants. How can researchers ensure the privacy and confidentiality of participants? I mentioned about the informed consent. So this means that researchers must inform participants about the nature of the study, including how the data will be used, stored, or protected. So clear communication is important because this helps participants make informed decisions about their involvement. A written consent form should outline the study's goal, the participants' rights and privacy protections, including the option to withdraw from the study at any time without a consequence. Researchers should remove personally identifiable information, PII, from the data, names, addresses, before it is analyzed or shared. So this helps ensure that the data cannot be linked back to individual participants. And de-identification, when a complete anonymization is not possible, the data can be de-identified by replacing personal identifiers with unique codes or pseudonyms, making it harder to trace data back to a specific person. Data encryption. Encrypt sensitive data. All digital data, especially when stored or transmitted, should be encrypted to prevent unauthorized access. This includes encrypting data on hard drives, cloud storage, and during transmission over the internet. Secure storage data should be stored in a secure location to limit the risk of unauthorized access. Controlled access means limited access to data. Researchers should only collect the minimum amount of information necessary for the research, reducing the risk of unnecessary exposure of sensitive data. Avoid collecting unnecessary personal identifiers, or collect only relevant data, for example, demographic information that is necessary for analysis. This reduces privacy risks. Secure data disposal. So after the completion of a study, all the data is no longer needed. Researchers should securely delete or destroy personal data to prevent unauthorized access. Shredding physical documents. If physical records are used, then they should be shredded when no longer needed. Confidentiality agreements. Researchers, staff, and collaborators should sign confidential agreements to ensure that they stand and committed to protecting the privacy of participants. Research staff should be trained in the ethical handling of confidential data, including the importance of privacy and the methods for securely managing data. The ethics review and oversight, this is extremely important. Researchers should always be in contact with ethical review boards in their institution. Researchers should submit the research protocols to IRB or ethics committee for approval. This ensures that privacy concerns are addressed from the outset and that the study adheres to ethical standards. The research team should periodically review privacy protections to ensure that they are being followed throughout the study. And of course, transparency. This includes ongoing communication. Researchers should keep continuously informed about how the data is being used and the measures taken to ensure privacy. So participants should be notified if there are any changes to the way the data is handled during the study. Aggregate reporting. If results are published or shared, they should be presented in a way that ensures individual participants cannot be identified through aggregate data or anonymized data sets. And when we share data with other researchers, strict protocols should be followed in order to ensure that the data remains identified and is used appropriately. If we incorporate these practices into our research design and execution, then we can uphold our confidentiality and privacy of our participants while ensuring ethical and responsible conduct throughout our study. For data collection and analysis, just to say some things that the common methods for collecting the research data. Yes, we all know about surveys, questionnaires, interviews, observations, experiments, case studies, secondary data, document analysis, focus groups, content analysis, action research, etc. How do you choose now the appropriate method for research? You need to define your research question to consider the data that you need. You can choose between experimental and experimental approaches. You need to consider your research design, to consider ethical applications, to review existing literature, to try to consult with advisors. And at the end, on a pilot basis, it's you can test in a pilot way. Before committing fully to your chosen method, you can consider conducting a small pilot study in order to test your approach and see if it will yield useful data. So here I think is a very important, it's interesting to see what basic tools and software are available for data analysis. Of course, some of them are AI. There are numerous tools and softwares available for data analysis. Spreadsheets, example. These are very common. The Google Sheets, statistical analysis software, SPSS. We will have a chance to explore this software. It's widely used in social sciences and research. It provides extensive statistical functions, including the test of ANOVA regression analysis. It has a graphical user interface. Another software is a statistical analysis system. It's a comprehensive analytics tool used by businesses and researchers for data analysis data. It's popular in economic social sciences. Programming language for data analysis, R is a free open source programming language specifically designed for statistical computing data visualization. Python, a general purpose programming language widely used for data analysis. And why Python is a versatile tool because it includes libraries like Pandas, NumPy, Matplotlib, and SciPy. Data visualization tools, the most popular, I think it's an amazing tool, it's Tableau. It's a user-friendly data visualization tool because we can see the connections of papers, we can visualize our papers, we can visualize our results. This allows users to create interactive dashboards with drag-and-drop features. Another tool is Power BI. Has a similar interface to Excel, integrates well with Microsoft products. ClickView, ClickSense, business intelligence tools, which also includes data visualization. For data cleaning transformation tools, Trifacta, a tool designed for data wrangling, allowing users to clean and transform data with a more user-friendly interface. OpenRefine, an open source tool for working with messy data. Many, have seen, if we add also AI, we have amazing tools, big data tools. Apache Hadoop, it's the most popular, Apache Spark. The first one is an open source framework that we use in order to process large data sets in a distributed computing environment. And Apache Spark, on the other hand, is a fast general purpose cluster computer system. In another session, we can say the difference between the two and which is the best for which condition. Survey and data collection tools, Qualtrics, SurveyMonkey, Survey, machine learning programs, Google Colab, RapidMiner, a data science platform used for machine learning, data mining, predictive analytics, geospatial analysis tools, ArcGIS, tool for spatial data analysis, the Quantum GIS, and some of the tools that we talk about, beginner-friendly, the advanced statistical analysis, big data, geospatial data cleaning. Choosing the right tools, we need to be very careful about this. And for academic writing presentation, the key components of typical research paper. Another time we will do analytically this. Of course, every research paper should include the title and abstract, introduction, literature review, background, the methods of research, discussion, conclusion, references, the acknowledgements, appendices. We will dedicate a whole session about this. It's very important, analytically, just to say here that, for example, discussion, here we need to interpret, analyze the results in the context of the research question, existing literature. And the key elements here is the interpretation of results, the comparison with different previous studies, the implication, limitations. For conclusion, we need to provide a summary of the key findings, their significance, so our conclusions should be concise, etc. So we will explore a lot about things in another session for references, for acknowledgement, for appendices. Of course, in our introduction, you need to be aware of this, all these types of plagiarism, direct plagiarism, when we copy someone else's work, word for word without giving credit. Paraphrasing plagiarism is another type when we rewrite someone else's ideas or text in our own words without citation. It again is another form of plagiarism. Self-plagiarism when we reuse our own previously published work without disclosure. Mosaic plagiarism, when we borrow phrases or ideas from a source and weaving them into our own work without proper citation. And accidental plagiarism, when we fail to cite sources correctly due to oversight or misunderstanding. How to avoid plagiarism? Of course, if we always give credit to the original source, so proper citation, this includes quoting, paraphrasing, or summarizing others' works, and this ensures that we follow the appropriate citation style, that could be APA or MLA, Chicago, etc. When you paraphrase, make sure that you rewrite the idea completely in your own words and still provide a citation. Keep track of sources while researching. Take note of all the sources you consult so you can easily reference them when writing. Use plagiarism detection tools like Eternity, Grammarly, Copyscape. This can help identify potential plagiarism in your work before submitting it. Understand fair use. If you use copyrighted materials like images or videos, understand the fair use policies and give a proper attribution. For short phrases, direct quotes or specific data, you can use quotation marks inside the source. For longer sections, paraphrasing or summarizing should be done with clear attribution. So this has to do with coding. And why avoid plagiarism? Because academic, professional, and creative environments value originality and honesty. Because plagiarism can damage your reputation, your credibility, your academic, professional integrity, and of course, in some cases, plagiarism can result in legal action, especially with copyrighted works. So, how should reference citation be handled in academic writing? In another session, we can analyze this just to say that you need to handle the type of citation, how to cite different types of sources, how we cite books, for example, journal articles or websites. There are different types of citations, how we cite different types of sources, redundant quotes or paraphrasing. Check about the popular citation styles. You need to know about the popular citation styles, like American Psychological Association, APA. Why it is important? Because we avoid plagiarism, because of academic data, I mentioned before, because this allowed verification. Critical thinking, problem solving, it's important in all these aspects, and on what we talk about academic research. Because this ensures objectivity and bias analysis, promotes a deeper understanding of the topic, strengthens the academic rigor of research, and supports lifelong learning adaptability. So how can researchers identify biases in their own work or in the sources they use? They need to reflect on their assumptions and hypotheses, to be transparent about methodology, be aware of the confirmation bias, check for selection bias. We need to explain in another session each one of these biases, assess the author's background affiliation, how to identify bias in sources, how to look for evidence of peer review, how to cross-check information with other sources, how to be wary of cherry-picking data, the tools to detect bias, bias detection software, data analysis, critical thinking, maintain objectivity, remain open-minded throughout the research process, and allow evidence to shape your conclusions rather than forcing results in order to fit your own expectations. So I will stop here, but as I said before, in another session, we're going to explore in more details the components of our research design more in details. For any question.
Okay, fantastic. Dr. Rania, you have given a lot of points for our audience to learn from. And dear audience, if you don't get any of the part, please explore further, research, know more about it. Maybe you can find more material under certain subtopics, or if you have any problem, you can also put in the comment section. Dr. Rania will be very much pleased to answer you. Yeah. So till we meet again in next topic, next Thursday, again on this Understanding Research series. Thank you so much. Thank you, Dr. Rania. Thank you so much.
Thank you. Thank
Yeah.
you. Thank you
Have a
very
great
much.
weekend. Yes.
See you
Bye-bye.
next Thursday.
Yeah, next Thursday. And tomorrow we are having Coffee with Estera with Professor Rania, yeah, on our space program and her journey with Greek astronomy. And as an academic, as well as, a speaker, an author. So let's hear let's check tomorrow. Thank you. Bye.